So what you're looking at here is an experiment in artificial intelligence. Each of these little colored individuals has their own artificial neural network. When they overlap with each other, health flows from one into another based on a certain program. As you can see, this was the individual just consumed, and this one ate him, or one of them did. Eventually, after an individual gets enough health, like I believe this one is about to, they have an offspring. Perfect, just in time. So the offspring is colored almost it's the same. You can see a slight difference here. The coloration is varied slightly, and the weights of the neural networks are weighted ever so slightly. 0.366, 0.388, by some random small amount. So therefore, they'll have slightly different opinions on things, different actions will be taken by them, which may be more or less successful. The more successful ones will live on to propagate, and by natural selection, Darwinian evolution, you should eventually get some pretty smart little blobs. Now, I just started this simulation, so everyone's pretty much just bumping into each other and moving around and not knowing what's happening. But if I were to load up a blob from a previous program that had evolved for a while, then we may see some more interesting things. It loaded up in the corner. Now watch it move. It's following that blue one the best it can. It's not perfect. Okay, it's going to go off the screen. It'll just appear on the other side, though. Oh, unless it just... There he is. Come here. I can grab it and move it around as well. Now, this one, I think it may have more neurons. Let's see. Actually, it looks like it has the same number of neurons as the rest of them. Let's see if we bring him closer to someone that he might want to eat. See if he'll go for anyone. So the green rings in the little individual's point of view down here indicate whether to the viewer whether they could eat it or not. So green means he can eat it. Bring it near let's see, maybe this red one. The red one he can't eat. How about? Oh, well, that was more blue. Alright, now you can see this guy's actually getting eaten by him. Maybe he's not so smart after all. Let's try loading somebody else up. There we go. Like this dark green blob. Let's open him up. See, where did he land? Let's close some of these. There he is. You can see he's marked after I loaded him. You can unmark them, I think, with the middle mouse button. Alright, so let's see if he's any good. Looks like he wants that guy. Oh, is he gonna... Oh yeah, he's really after that blue guy. See, he turned all the way around to keep with him, and now he's staying overlapped. So he is consuming that blue guy, and he looks like he's going to have an offspring. There he goes. And the blue guy's gone, and he suddenly changed directions. Now he's kind of going towards this one with the red ring, but oops, now there's somebody else for him to grab. Oh, he changed his mind at that angle. Now here he is near his offspring. Sometimes they nibble on each other, sometimes they don't. Oh, there he is grabbing a blue guy. Perfect. Alright, so the inputs to the neural networks are over here. The ones in white at the top are the relative polar coordinates to the nearest other blob. We've got the colors of the nearest one and his own colors. When you create a new blob, you can choose a lot of different things about them. Their color, you can actually make them capable of perceiving more than as many enemies as you want, provided you give them a large enough brain. Every time you add an enemy, it adds a lot of inputs to the neural network. So we should make the brain bigger, and I hope our computer can handle it. And let's do like 5 after all, see how that looks. So I'm going to add in this sort of orange guy. There he went. Ooh, I should have checked the box that would have marked him. Now, if you look at the complexity of his brain, theoretically, he'll be capable of a lot more intelligence than the others. The trouble is that when pitted against symbol-minded ones, these actually do a little worse, because when they can view that many enemies, well, they tend to jitter around a lot and tend to get eaten. But in any event, here's you can see in his little view in the corner there that he's looking at, looks like it's 4 others. I thought that I had said 5, so there could be... Oh yeah, there are 5. Must have been overlapping each other. Okay. You can run the simulation in faster time to let things to let them evolve much quicker. It's just turned off some of the niceties, and it's only rendering every few frames with no intended time delay, so it'll run as fast as your computer can handle it. And after a while, you can turn it back off and see if anyone's doing anything interesting. If you want to try and figure out who's winning, well, it's hard to just tell by staring, so you can view the details, and you can sort by, say, the number of offspring here, because the ones that have the most offspring are probably the most successful. Oh, and look, it appears to be one of our dark green guys that I loaded up from a previous simulation. So, in case you don't know, artificial neural networks are an artificial intelligence implementation for computer science. They try to mimic these real biological networks, brains basically. They mimic those and try to make decisions like a human would. Like I mentioned, they work on natural selection, and we do indeed seem to be seeing some sort of evolution of intellect in a fight or flight response. The consumption preference goes like this. I just decided randomly and wrote a function that would base the nutritional content. So a red one would consume mostly green ones, or at least it would be able to. But if a blue one overlapped a red one, then the red one would be eaten, and all of his health would go into the blue one. So I just made this choice. It's a little hard to tell sometimes because they can be pink in any color they want, but if you examine the code, you'll see how the function basically works in this, as this diagram indicates. Speaking of which, it's a Java program. It's largely serial. It would have been good to implement it in a more parallel fashion, but I'm focused in Java. I implemented the neural nodes and the neural network myself for practice. And if you want to download this program, that's jar to play with, it's below the video, and so is the GitHub project. If you wanted to fork that and look at the code and work on it yourself, I'd be very interested. So here are some future ideas that you might think of. I was thinking to give some of the individuals memories. You could feed back the output from the neural network back into one of the nodes. There are other activation functions that could be tried, certainly. And of course, it could really benefit from running in parallel. And to compare it with other training methods, another fun thing to do would be to try to calculate the weights yourself to result in a successful one. I tried that a couple of times and it just did not work at all. I could not get them to survive, but I may give it another shot, or probably what I should do is write a little program, create a node yourself, or a little blob, I call them, or individuals. And that's about it. Looks like our green guys have really taken over. That's what's bound to happen when they're intelligent enough. Trouble is, once they eat everyone else, then it'll be all them, and they'll all be intelligent enough to sort of avoid each other, and, well, no one starts to get that no one gets much smarter after that happens. So that's about it. I think I'm supposed to tell you to like and subscribe or share, bell, do the bell comment and add a comment, and all those things. So do that. Bye. Oh, and by the way, I am aware of the terrifying philosophical and ethical questions or issues this brings up every time I create one of these simulations and they do their thing. Well, every time I let them live and then clear the simulation, I've destroyed an entire civilization. So yeah, discuss, please. I'm very interested on such thoughts. That's not really what I spend my time on, so I'm sure you can blow my mind pretty easily in the comments. That's about it again.